Hello, Algebra 2. Welcome back. Happy Thursday. So, we have already reviewed two methods to solve linear systems. We have reviewed graphing on Tuesday, and yesterday we talked about substitution. Today's our final method of how to find that point of intersection, that ordered pair shared between two lines. This method is called elimination. Now, elimination is going to be similar to substitution in that it's symbolic. We're using letters and we're writing stuff down. We're not, drawing a picture or anything. But it does have a special case in that it's a bit easier to use sometimes than others. So there are going to be times when we want to use substitution and times when we want to use elimination. And we're going to determine those cases today. So let's get started. Elimination. The basic understanding of elimination is that we can add multiples of two equations together. We can add multiples of two equations together in order to cancel out one variable and find a solution if it exists. An example of this is if we had the equation x plus y equals 2. We're trying to find its point of intersection, its solution, with the equation 5x minus y is equal to 6. We could actually add these two equations together to solve for that ordered pair. So here, if we remember our like terms and we add everything with x's together, so x plus 5x gives us 6x, and everything with y's together, so y and negative y make 0y, or just 0, and then everything without any variables together, 2 and 6 gives us 8. We will be left with an equation with just one variable. 6x equals 8, which gives us x is equal to 4 over 3. So while on Tuesday and on Wednesday we might have used substitution or graphing in order to solve this, in this case it was actually more efficient to use elimination. Why is that? It's particularly because of these y's here. Right here, because we see that positive y and that negative y, that when we do add these two equations together, they cancel out to 0, and we're just left with x's, and we can easily solve for that x value. All right. Why does this make sense? It's kind of like if we had two scales. You don't have to draw this down. This is just a demonstration, so just use your eyes for this one. You know those like old-time scales where like they like weighed money on this? Oops. Well, there we go. And then like maybe we had like limes on this one. And we know that like the weight of 4 limes is equal to like an apple's weight or something. There's my apple. And then we have a second scale that just has, let's see, here's our second scale, and it just says that, hey, 3 blueberries, the weight of 3 blueberries is the same as like 3 blueberries. Basically, what we're saying is that if we add everything together on each side of these scales, almost like if we added up the sum of each side of the scales, like the sum of each side of an equation, we will still get a balanced scale. So if we have all 4 of those limes plus those 3 blueberries, and on the other side we had those 3 blueberries plus that apple, our scale is still imbalanced. Our scale is still balanced and it is not imbalanced. It's not doing, like how these scales like to tip. If I was here right now, I would like tilt my body like this scale. It's we still have an equal weight on each side of the scale. And the same thing is happening with equations with elimination. All right, let's go back to our notes. So we noted that we can add multiples of two equations together in order to cancel out one variable and find a solution. Let's do that all together in number 1. We're going to finish our notes underneath that sentence there, but let's start with that example first and then go back to those notes. So here, looking at this problem, I already see a positive 4x and a negative 4x in these equations. And I know that if I add 4x and negative 4x together, I'm going to get 0. And that makes me happy, and that makes me want to use elimination. So let's add these two equations together. Keep in mind, we will keep that equal sign and just carry that down, and keep everything on the left-hand side on the left, and everything on the right-hand side on the right. Let's start with the left-hand side. So negative 4x and positive 4x, that's going to give us 0 or 0x. If you want to write 0x, you can. If you don't want to write anything there, that's fine as well. 8y and negative 2y, combining those like terms, we should get plus 6y. And then on the right-hand side of the equation, that negative 12 and negative 24 should give us negative 36. And now we just have an equation with one variable. Because 0 times x is 0, we're just left with 6y is equal to 36. So when we divide both sides by 6, we get y is equal to 6. Keen beans. Instead of saying cool beans, I studied abroad in Scotland and then had some English friends and they always said keen beans. Actually, she was Welsh, but keen beans. So we found our y, we need to find our x now. Once we find this one variable, our next step is just going to be to plug back into any of the original two equations to solve for that other part of the ordered pair. I'm going to put that in our notes before we actually do it in this example. So once you solve for one variable, plug that value back into either of the original, the OG equations for that second value, for the second variable value. This is because, just like yesterday, what we want, our solution is going to be that xy pair. So going back to number 1, we've got our y is equal to 6. I'm going to do this work off to the left so I have space. We can choose either of these equations to plug y back into. I'm going to choose the second one just because it has less negative numbers, because I don't like to work with negative numbers. So when you plug that back in, we get 4x plus 8 times 6 equals negative 24. Start evaluating. 4x plus 48 equals negative 24. Once you subtract that 48 from both sides, and then divide by 4, we should get x is equal to negative 15. So our ordered pair, our final solution is negative 15, comma 6. Neat, 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 neat. Okay, if you wanted to check this, we could plug negative 15 and 6 back in for x and y in that second equation, or the first one. Probably the second one, since we just used that first equation, we would plug into the second one. But For the sake of time, let's move on. Number 2, it gives us negative 6x plus 6y is equal to 6, and negative 6x plus 3y is equal to negative 12. Okay, instinctively, I see a negative 6x and a negative 6x. Don't write down what I'm about to do. Do not write this down. I'm going to make a mistake. If I added these two equations together, using the elimination method, I would get negative 12x plus 9y equals negative 6. Don't write this down. Ooh. Problem. None of my variables canceled. I still have x's, and I still have y's, and so I can't solve for one of these variables now. That's because negative 6x and negative 6x, when we add them, they do not cancel out to 0. So we have to do something differently. What we can do is subtract these two equations. So let's add that to our notes. Under here, I'm going to write, we can subtract equations, EQs, as well. Note that this is the same as adding or the same as multiplying that one equation by 1 and then by negative 1 and then adding. So the same as adding multiple of negative 1. Wait, yeah, no, first version is better. Same as multiplying by negative 1, multiplying by negative 1, and adding. Okay. So let's subtract these two equations. So if we have negative 6x minus a negative 6x, that's really negative 6x plus 6x, which will give us 0 with these two terms. Okay. 6y minus 3y will give us positive 3y. Carry down that equal sign. 6 minus a negative 12. Now be careful here. We're subtracting a negative, so this is really 6 plus 12, which should get us 18. And now we've canceled out our x's, so we're happy. We're just going to solve for y now by dividing both sides by 3. Get y is equal to 6. All right, on your own, try plugging this back into one of your original equations. Either one will work, and determine what that x value should be. You don't have to pause this time, just do it on your own. All right, x should be positive 5. X is positive 5, which gives us 5 comma 6 is our solution. Neat. Neat, neat, neat. All right, last but not least, number 3. Ooh. 7x is equal to negative 19 minus y. Negative 2x plus 3y is equal to negative 19. Okay, looking at this, let's go through this. Our x's, we have negative 7 and negative 2. Those aren't going to cancel unless we multiply by some multiples. Ugh, that's kind of messy. 3y and negative y are on opposite sides of the equation. Also messy. Oh, the negative 19s are on the same side of the equation, but we don't want to cancel out the constants. We want to cancel out one of those variables. I'm going to show you what you could do. Let's see. Let's take this top equation, and we're going to rework it. I'm going to add y to both sides of this top equation. So we get y minus 7x equals negative 19. Yeah. That second equation, let's see, let's add 2x to both sides. So we get 3y equals 2x minus 19. Notice that although I have the y's in the same side of the equation now, oh my god, like nothing is still going to cancel. At this point, I'm just going to recommend don't even use the elimination method. Personally, I would rather just solve for y in this first equation and then use the substitution method. Use substitution here. Substitution, because all of this work of moving things over and then multiplying by some multiple is just, it's a lot. Let's just do substitution. So for the sake of time, let's skip that for now. I want to make sure we get to these story problems. All right, number 4. Gerald received a total score of 1340 on the SAT. His math score was 400 points, less than twice his verbal score. What was his score on both parts of the test? Okay, so you've got two different scores here, his math score and his verbal score. And verbal is just, that's like his English score, right? And his math score and his verbal score both compose his total score. So I'm going to define my variables as x will be his math score, y will be his verbal score, and let's write the equations given these definitions now. Okay, so we know that x plus y must equal 1340, because both of these compose that total score, and now his math score was 400 points less than twice his verbal score. So that means x was, so 400 points less than twice his verbal score. So if we take his verbal score, y, we multiply it by 2, and then subtract 400, we will get his math score. Oh, great. Looking good, looking good. Okay. At this point, we have one of two options. We could solve this using substitution, where we would just take, because we've already solved for x with one of these equations, just take this bit here, 2y minus 400, and plug that in for the x in the previous equation. Or we could do elimination. I'm going to show you the elimination method. If we subtract these two equations. So here, okay, our x's are on the same side, and when we subtract x from x, we will get 0. I'll draw that equal sign in the middle. Here we go. When we subtract, let's see, there's nothing else on the left-hand side of the bottom equation. There's just the y on the left-hand side of the top equation. So just 0 plus y equals, now 13,400 minus a negative 400 will give us 1740. And then we're subtracting 2y from nothing really, minus 2y. All right. Last steps here, let's add 2y to both sides. We get 3y is equal to 1740. Also note that we are nice and happy because after doing the elimination method, we were left with only one variable, so we did something right. We're feeling good. At this point, when we divide by 3, we should get y is equal to 580. And that will give us an x value of, when we plug it back into the first equation, so what plus 540 equals 1340, should get 760. So what was his score on both parts of the test? 760 was his score on the math, and 580 was his score on the verbal. Either method here works for either substitution or elimination, so whichever one seems easier to you, feel free to use it. It is good to be flexible with both, and I encourage you to try out both, especially on your homework. If it asks you to do elimination, try elimination just so you get the practice in. Later on in math, you can choose whichever, but try elimination just to get that in. All right. For number 5, let's at least set up the problem and say what we would do from there. So a concession stand sells hot dogs and sodas. John bought 6 hot dogs and 4 sodas and paid $6.70. Jessica bought 4 hot dogs and 3 sodas and paid $4.65. What is the price of 1 hot dog? What is the price of 1 soda? So it sounds like we're looking for the price of a hot dog and the price of soda. And let's let this be our x and our y, although we could really choose any variables. We know that John bought 6 of these hot dogs, 6x, and 4 of those sodas, and paid $6.70. Okay, that's a lot of hot dogs and soda. Wow. Jessica bought 4 hot dogs, 4x, and 3 sodas, 3y, and paid $4.65. All right, what I want you to do now is turn to the partner, like an elbow partner, and discuss, would you rather use elimination or substitution here, and why? So you don't have to pause, I'll just stop talking. Take about 1 minute, go. Thirty more seconds. All right, I think that was enough time. I'm going to cut you guys off right there. Sorry for the early cutoff. So, I cannot call on one of you right now. I can call on myself. Basically, we could use elimination here, and we could use substitution. Honestly, this problem is presenting a lot of different numbers that's making both a little bit tricky, but we're going to power through it. If we did want to use elimination right now, 6x and 4x will not cancel to 0 if we add or subtract. Same with 3y and 4y. So what we're going to have to do is multiply these by some number, both equations, by a different number in order to get either the x's to match up or the y's to match up. I'm just going to choose to have the y's match up just because they're smaller numbers and they're a little bit easier to work with. So let's multiply. Let's see, we have 3y and 4y. The least common multiple of 3 and 4 is 12. So let's multiply this top equation, everything in that top equation, by 3, and everything in this bottom equation by 4, just so that both equations have 12y in it. When we do this, our top equation is going to become 18x plus 12y equals, mental math, 20.1. And then that bottom equation, I'll let you get that down. Our bottom equation is going to be 16x plus 12y equals 18.6. And now we're happy. Now we have 12 y's in both of these equations. So we can subtract these equations now, and these 12 y's are going to cancel out, and we'll just be left with x's. So go ahead and do this. I will leave the answer behind the Algebra II CP board. Just have someone remove it when it looks like the majority of the class could use that answer. So go to. Please pause. All right, once everyone has completed this problem, please remove the Algebra II CP board. Double check your work. You could have plugged it into the first equation. I chose to plug my x back into the second equation. Either one works, but you should come out with the same answers of 75 cents and 55 cents. So thank you to whoever removed that board for the check. You rock. All right, that is the extent of me leading your notes today. All you have left to do is solve this last linear system on the back. You're going to solve it by graphing, by using substitution, and using elimination. Please pause this video once again. Once you unpause it, you will reveal my work for this. Please check your work, and then note your homework at the bottom here. It is, how many problems did I give you? 1, 2, 3, 4, 5, 6 problems. You might have time to complete, get a head start of them at the end of class. But make sure you've completed all 3 methods. This is a great review for your homework quiz tomorrow. Let me know if you have any questions. Please feel free to send me an email. Miss you all, and I will see you soon. Oh wait, please pause the video, and now you can reveal the answer after. Please pause. And unpause. Let me zoom out. Boom. There we go. Yep. Feel free to keep this image up here if you want to come up to the board and check your answer. That is it for today. Please have a wonderful Thursday, and I will see you all tomorrow. All right, bye-bye.